today for lesson 15, we're going to go over using the quadratic formula. Last time we worked with solving by completing the square. This time we're going to solve using the quadratic formula. I'm going to introduce it later on, and we're going to use it for equations that are a little bit more difficult or challenging than the normal ones we'd be working with. So I want you to work with A and B. On A and B both, you're going to pick the best way to solve it. So you have to move these things around, set it equal to 0, and then you can use either completing the square or factoring to solve these. So once you work with those two, then come back, and this should be a refresher. I'll help you with them, and then we'll move on to working with the quadratic formula. So give them a try. Okay, for the top one here, so we're going to end up having to move over this 2x squared and negative 3x to the other side, so we'll have to do the opposite. So for the 2x squared, we're subtracting 2x squared. Then we'll take the 3x and add it to each side. So we're going to get 2x squared plus 8x plus 3, and that's going to be equal to 0. So for this one, if you were to try and factor it out, you're not going to get a nice breakdown for it. So instead, the better way to solve this one is going to be by completing the square. So I'd subtract 3 from each side, so we get 2x squared plus 8x equals negative 3. So then the next step we can try to do is we're going to pull out this 2. So we'll have 2x squared plus 4x equals negative 3. And then we'll end up dividing this 2 over. That way we can get rid of it. So we'll divide this side by 2 and the other side by 2. So if we bring this over, now we're going to have x squared plus 4x. That's going to equal negative 3 over 2. So we need to figure out what is going to complete the square. So for this one here, we'll take, if you're using the box, you'll have x squared, split 4x into 2, so you have 2x and 2x. And then you'll see what your sides would be. So x times 2 will give us 2x, x times 2 will give us 2x, and then 2 times 2 will be 4. So we need to add 4 to this side and 4 to the other side. So then over here, we're going to get x plus 2 squared, since this is what we have on the sides up here. And on this side, we're going to have, it would be negative 3 over 2 plus 8 over 2. So we'll end up having 5 over 2, or 2.5. So then the next step, we'll square root each side. So we're going to get x plus 2, and that's going to equal square root of 5 over 2, or square root of 2. So we can split it up, or we can just leave it square root of 5 over 2. Actually, we'll go ahead and make it one big one, 5 over 2, and it's a plus or minus. So the last step will be subtracting 2 from each side. So x is going to equal plus or minus the square root of 5 over 2 minus 2. And so that's how we'd be able to work with that one. So then for the second one, it's actually going to end up being fairly nice because you just end up factoring this one out. So for this one here, we're going to subtract 5c from each side. So we're going to get c squared minus 5c minus 14. If you wanted to, you could try completing the square. It's just going to take longer than we need to work with it. So for this one, when we factor it out, since there's a coefficient of 1 in front of the c, it's going to be c and c. And then negative 14, and we can find factors of that. So negative 7 times 2, negative 2 times 7, 14 times negative 1, negative 14 times 1. So the ones that when we add them together, we get negative 5. It's going to be negative 7 and 2. So minus 7 and plus 2. So the last thing we need to do to solve this one for c is set both of these equal to 0. So for this one, if c is 7, then this becomes 0. So c equals 7. And for this one here, it would be negative 2. So there would be our answers there. C equals 7 or C equals negative 2. So for both of these, we can use methods that we already know. Completing the square is going to work on quite a few, but it can become complex and difficult and just kind of unnecessary to work with. So instead, we have the quadratic formula. So the quadratic formula you can derive from the standard form. So working through that and what we did last time. So for this one here, you have to remember that it's ax squared plus bx plus c. And so these values, the coefficients, are what you're going to plug into this. So the b here equals this b. So it's negative b, and you have b squared. The a you're going to have in place of these two a's, and the c you'll place in this c. So you're going to essentially plug in the coefficients into these numbers and see what your answers are going to be, and that would equal x. So just as an example, I'll show you here with this one down here. So for this one, we're going to have, I'll write it here also so that you can see it. So b squared minus 4ac over 2a. So we need to list out our coefficients. So a is going to equal 1. We'd have a 1 in front of there. For b will equal negative 2 right there. And c is going to equal 1. So anytime we see those spots, we'll plug it in. So for b, for this one, we'll have negative times the negative, so they'll cancel out. It'll be a positive 2 plus or minus. And then you'll have square root of negative 2 squared minus 4 times 1 times 1. Okay, and this will all be over 2 times 1 for the a. And then this will equal x. So we'll have to do this 2 different times. We have to do one where it's positive and one where it's negative. So we're going to work this part out here first. That way we can know what we're working with. So we have 2 plus or minus square root of. So negative 2 squared is going to be 4. Negative 4 times 1 is negative 4. And that's all over 2 times 1, which is going to be 2. So we can just, again, shorten that one. 4 minus 4 is going to end up being 0. So 0 square root of 0 plus or minus 2 over 2. So for this one here, the square root of 0 is going to be 0. So when we have that, you add or subtract 0 from anything, it's only going to be 2. So this ends up kind of canceling itself out. So that's going to be equaling 2 over 2, and 2 over 2 is going to equal 1. So x equals 1. And so that would be how we would work through this. Now we could go through and check it. So we plug 1 in. So 1 squared minus 2 times 1 plus 1 equals 0. So 1 squared is 1. Negative 2 times 1 is negative 2. Plus 1 equals 0. And so we get 0 equals 0. And so we can go through and check it. So this is one method of using it. So we'll go on to number 2. So on number 2, again, I would write it out so that you have it. Negative b plus or minus the square root of b squared minus 4ac, all that over 2a. So for this one here, again, I would list out my a is going to equal 3. Our b is going to be 4. And then our c is 8. So do not get it mixed up with your variable here. It's not the variable. We're talking about the coefficient in the front. So when we see 4, or when we see b, we'll plug in negative or 4, which will be becoming negative 4, plus or minus the square root. So now we'll have 4 squared. It's going to be minus 4 times 3 times 8. And then all that's going to be 2 times 3. So again, simplify, but do the things under the radical first. So we're going to have negative 4 plus or minus, and it'll be the square root, 16. And then we'll have to do negative 4 times 3 times 8. I do not know off the top of my head. Okay, so negative 4 times 3 times 8, and you'll get negative 96. all that's going to be over 2 times 3, that'll be 6. So I'll rewrite it out, -4 plus or minus, it's going to be square root. So 16 minus 96 is going to be -80, and that's over 6. Okay, for this one, this is where we're going to have to stop. If you were to type in on your calculator, and I'll show it with this one, you do square root of -80. I don't know if you can see that. It's going to say domain error. So you cannot do that. That will not give you a number. The reason is because it's not a real number, so you won't have any real solutions for this. So for this one, we'd say no real solutions. Since this is a negative under here, you can't have a square root of a negative number. It's kind of like when you divide by 0. It's not going to give you a real number. So for this one here, we'd have no real solutions, and that's where we would stop. So once we see that, we would just stop there. So I want you to practice with 3, 4, and 5. Just get a little bit of practice working with the quadratic formula, and then come back and I will work through them with you. Okay, on number 3 here, I went ahead and just wrote out a equals 2, b equals 7, and c equals -4, and I plugged it in the quadratic formula over here. So if we want to reduce it, you're going to get -7 plus or minus the square root of 49, and it's going to be, you'll have two negatives, so it'll be in positive, so it'll be 4 times 2. You'll get 32, so it'll be plus 32, and that'll be over 4. So 49 plus 32, not times, 49 plus 32 is going to be an 81. So we have -7 plus or minus the square root of 81 over 4. For this one here, it's 81. We do know what that square root is, so we can end up getting a rational number out of this. So we're going to have 9. 9 would be the square root. So we have plus or minus 9 over 4. So then this one we'll have to do two different ones. So x is either going to equal -7 plus 9 over 4, or it's going to be x equals -7 minus 9 over 4. So those would be our two options. So we'll just reduce them. So -7 plus 9 is going to be 2 over 4. It's going to equal a half. So x can equal a half, or -7 minus 9 is going to be -16 over 4. That's going to equal -4. So there are the two answers that we could end up getting for this one. So if you do know what the number is when you square it out, then I would suggest going through and solving it. So on 4, now we're going to do the same thing. A equals 1, b equals -2, c equals -1. So we'll have 2 plus or minus the square root, -2 squared, minus 4 times 1 times -1. And that's all going to be over 2 times 1. So if we're reducing it down, 2 plus or minus the square root of 4, that would be -2 squared. And this one will be -4 times 1 times -1. So positive 4, all that over 2. So this is going to be equal to 2 plus or minus the square root of 8 over 2. So for this one here, we're not going to know exactly what this is, but we can break this answer down a little bit more. So the way we can do this is actually by splitting this up. We can do this part divided by 8 as well as this part divided by 2. So the square root of 8 divided by 2, and 2 divided by 2. So it'd be like writing it out like this. Something important to keep in mind is that this square root only applies to the 8. It does not apply to the 2. So if we do 2 over 2, that's going to equal 1. And then we do plus or minus the square root of 8 over 2. So you just have to make sure that you write it out that way. So x is going to end up equaling this right here. So we'd reduce it down, split the 2 up so that we divide each of them separately. Okay, and the last one here. So m squared, we're going to have to subtract this 3 over, minus 3, and so we'll end up getting minus 7 equals 0. So for this one here, now we're going to have a equals 1, b, there isn't a b here, so that means it's going to equal 0. And then c is going to equal negative 7. So we'd still set it up the same way. So we'd have 0 plus or minus the square root of, and it'll be 0 squared minus 4 times 1 times negative 7. And all that is over 2 times 1. So then the next thing, so the 0, we're not going to have that out in the front anymore. This will kind of go away. So it's just going to be negative 4 times 1 times negative 7. That's going to be square root of 28 over 2. Do not forget it's plus or minus, and that would be all you have to do for that one. So x, I guess this one would be a cube, but anyways, x equals plus or minus square root of 28 over 2. And so that's how you would finish with that one. So there is something that I want you to recognize through these. When we're working with these, there's this thing called the discriminant. So the discriminant is this right underneath the radical. So the b squared minus 4 times a times c, that is called the discriminant. So with this here, you can tell how many solutions there are going to be to an equation based off of this. So when we're looking at this, for this one right here, we found that our discriminant would be 0. So when our discriminant is 0, we only had one answer. So that's going to be important. When we worked with this one here, we had our discriminant and it was a negative number. We had no real solutions. It didn't work. On these last 3 that you worked through, our discriminant was a positive number. So for each one, we end up getting 2 different answers. When, let's see, for this one here on 3, we had a half and we had negative 4. For 4, we had 1 and plus or minus the square root of 8 over 2. That'll give us 2 answers. And we also have the plus or minus here. That'll give us 2 answers. So on the next page, I actually wrote this out. So the discriminant is going to be this value right here, b squared minus 4ac, and here's just kind of a guide. If it is greater than 0, there's going to be 2 solutions. If it's equal to 0, there's going to be 1 solution. And if it's less than 0, there will be 0 solutions. So when we're looking at it, when we're solving these, we're always solving them when y is going to equal 0. So when we look at these different graphs, just kind of putting these up here to show what the discriminant is going to tell us. For this one here, our parabola is going to come down and touch only at one spot. This is when the discriminant equals 0. If the discriminant equals 0, then it's only going to touch in one spot. So then this one here, the discriminant is going to equal a negative. The reason is it's not going to touch this x-axis. If it doesn't touch the x-axis, then we can't find a solution when we set them equal to 0. You can still graph it, but it's not going to have a real solution to it. So the last one here, the discriminant is a positive. Since it's a positive, it's going to go through 2 different points. So we would have 2 different solutions to these problems. So this is just something to kind of visually show you what exactly is going on with these. So what I want you to, well actually I'll work with you on 6, and then 7, 8, 9 I want you to go through and practice. So it says determine the number of real solutions for each quadratic equation without solving. So in order to do this, we have to move everything together. So for this one here, we have p squared. We're going to add 3p to each side. And when we do that, we'll get p squared plus 10p. And then we also have this 8 here. So we're going to subtract 8 from each side. So then we will get, it'll be plus 25. And that's all going to be equal to 0. So if we use our discriminant, we're going to have, if we want to list them out, a is going to equal 1, b equals 10, and c equals 25. So then we would plug this in. So 10 squared. So 10 squared minus 4 times A, which is 1, times C, which is 25. So we're going to get 100 minus, it will be negative 4 times 1 times 25, so it's going to be 100. That's going to equal 0. So the number of solutions we'd have one solution. And that's all you have to do for those ones. So I want you to work on that for 7, 8, and 9 as well. On this one here for number 7, all you have to do again is list out your A, B, and C. Our A is going to be 7, B is 2, and C is 5. So then we'll just plug that in. So we have 2 squared for B, and it's going to be minus 4 times A, which is 7, times 5, which is C. So for this one, we're going to get 4, and it's going to be minus, and this is just going to be a massive number in comparison. Let me double check. It'll be 140. So this one is going to equal negative 136. It's a negative number, so we have no real solutions. So we'd have no real solutions to this problem. So then for C, again, we'll have to move some things around. Minus y squared, minus 4y plus 3, minus y squared, minus 4y plus 3. So we'll get y squared plus 6y plus 3. And so our A is going to equal 1, our B equals 6, and our C equals 3. So then we'll plug those in for B squared. So we have 6 squared minus 4 times A, which is 1, times 3, which is C. So we'll have 36 minus 12, and that's going to equal 24. So we have a positive number, so we'll have 2 solutions. So 2 solutions. Okay, last one here. So for this one, we have to add 4z to each side. So add 4z, and we'll get 4z squared plus 4z plus 9. So A is going to equal 4, B equals 4, and C is going to equal 9. So we're going to have 4 squared minus 4 times 9. Again, this number is going to be much bigger. We would have 16 minus 144. That's an equal negative number. So we'd have no real solutions. Okay, so on the next part here, it says on the line below each graph, state whether the discriminant of each is positive, negative, or equal to 0. Then identify which graph matches the discriminant below. So for each one of these, we're going to work through this. So for graph 1, this one is going to end up touching right on the line. So this means that it's going to have a discriminant of 0. Since it touches on the line, it only has one solution. For this one, it's never going to cross the x-axis, so it would have a negative discriminant. So we'd have 0 solutions. For this one here, as we're going over, it's going to cross through 2, so it'll be a positive discriminant. And then this one here, it'll go through 2 as well, and it will be positive. So something also to pay attention to, these ones are on decimal points. This one will cross at 0 and at 4. So this discriminant is going to have a definite rational number, one that you can find a perfect square root for. So we'll go with this one here. So just working with this one, you take negative 2 squared, it's going to be 4, and it's going to be minus, it'll be negative 4 times 1 times 2, and that'll give us negative 8. So this one will have a negative, so this goes with graph 2. So then this one here for B, we're going to get 16 when we do negative 4 squared, and this one has negative 4 times negative 1 times negative 4, so it's going to be negative 16. So this one will end up equaling 0. That's going to be our graph 1. So this one right here, when we work with it, we're going to get 16, and it's going to be minus 4 times 1 times 0. So that ends up becoming 0. So 16, This one, we do know what the square root of it is, so this one would go with graph 4. The reason being that these would be numbers that we can actually work with. They'd be rational numbers. These ones are going to be irrational. We aren't going to be able to find exactly where that point is. So for this one here, you'd have negative 8 squared. That's going to be 64 minus 4, negative 4 times negative 1 times negative 13. So we're going to get negative 52. And so this one, you're going to get 12, which isn't going to be something to give us a rational number. So this goes with graph 3. So for this here, you can use your discriminant to figure out what kind of graph you're going to have. You can also use a graph to figure out how many solutions that you would have to the problems and even what the solutions are. For this one, it would be 0 and 4. We would know exactly that those are the solutions. So that is it for lesson 15, using the quadratic formula to solve them. Really, you want to use it when you can't factor or when completing the square is just kind of a monster to do, because it's easier, it's quicker to factor than to always just go directly to the quadratic formula. So I would definitely keep that in mind as you're working with these. Don't always go exactly for it, but sometimes it will be needed to solve these. But that's all I have for you, the quadratic factor or the quadratic formula and the discriminant. But that is it.